In the past couple of days, we've been looking at different differentiation rules. Yesterday was about the product rule. So remember, the product rule was when you had two different functions being multiplied together. So it was like p at x times q at x. And you would take the derivative of the first. So the derivative of this, of course, is the derivative of the first times the second plus the derivative of the second times the first. And we practiced a bunch of that. So it begs the question, what happens if instead of those functions being multiplied together like they are in yesterday's work, what happens when they're being divided? Does the rule look the same? I imagine if I had asked people in the class, people might guess that it is the same except with a minus in between, and they'd be very close. Which makes sense because, things like the exponent rules, when you take exponents for the same base, you can keep the base and add the exponents. If you divide them, you subtract the exponents. So it does make sense that maybe the quotient rule looks a lot like the product rule with a minus in it, and they'd be very, very close. This is what it looks like. It is the derivative of the first times the second minus the derivative of the second times the first, except this whole thing is being divided by the bottom squared. Okay, the quotient, or the bottom part squared. So I'll give you a second to write that down. I'm going to show you in a bit where it comes from. But what you need to know is the quotient rule is actually something that they took out of the curriculum, but we've decided to still teach it because it's so helpful for differentiating a bunch of different functions. I'll show you both ways that you can do it. You can choose which you'd like, but I haven't met a student who hasn't preferred using the quotient rule for these situations. So good news is we have the product rule, derivative of the first times the second plus the derivative of the second times the first. The quotient rule, instead of saying first and second, I'm going to say top and bottom. We still want that language out there, so the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So we'll take an example, we'll do it, we'll use the quotient rule, and then I'll show you where it comes from. So here's our first example that we're going to differentiate. It is f of x equals 1 over x, or sorry, 1 minus x, all over 1 plus x squared. So again, we want to make sure we identify which one's which, so I'm calling this top part obviously the top, and this bottom part the bottom. So when I go off and differentiate, I'm going to take the derivative of the top. Since it's just 1 minus x, the derivative of that is just negative 1. So the derivative of the top times the bottom, as is, minus, now the derivative of the bottom, which is just 2x, times the top, as is. So that should feel a lot like the product rule, just with a minus sign, all over the bottom as is squared. We don't do anything, just keep the bottom as is squared. Again, there's our calculus. Now we're just going to simplify. Oh, I think I said negative 1 when I took the derivative of the top. It is negative 1 there, so make sure you update your notes there. I'm going to rainbow that negative 1 in here. So it's minus 1 minus x squared. And on the other part, this is what's going to be different. I'm rainbowing 2x, sure, but it's a minus 2x. It's subtract 2x, so I might as well do it all in one step. So I'm going to rainbow a negative 2x, so it'll be minus 2x, and then plus 2x squared, all over 1 plus x squared, all squared. By the way, the bottom, you'll notice you could actually rainbow the bottom out, but it's going to make your life a little bit more difficult, so nobody really ever does that. They just leave it as is. Cleaning up the top then, you'll notice that I have a minus x squared and a plus 2x squared. So I'm going to bring those together. Minus 1 plus 2 is just 1x squared. The minus 2x doesn't have a like term, and the minus 1 doesn't. All over 1 plus x squared, all squared. That's it. That is the derivative of the original function, which happens to be a quotient. Okay, so pretty straightforward. Good news is it's similar to the product rule where derivative of the first times the second plus derivative of the second times the first, except here it's derivative of the top times the bottom minus derivative of the bottom times the top, and then this addition of all over the bottom squared. So I said I'd show you where it comes from, and I'm going to show it using this example. So all quotients can actually be changed into products. So this says that it's 1 minus x divided by 1 plus x squared. I can actually change this question into a product and say it's multiplied by the bottom but raised to the negative 1. So I can take that bottom thing and raise it to the negative 1. That brings it to the top. And I can change this question into a product rule. So that's what I'm going to do, and you're going to watch and see how the different parts of the quotient rule will pop up when I do it this way. The curriculum suggests why teach the curriculum, or why am I going to teach them the quotient rule when every quotient can be switched to a product rule and you just do the product rule. Well, you'll find that products like this are actually a little bit more difficult to differentiate. So it's good to have the quotient rule because we find it a little bit easier. But I'm going to go off and stick with this. So the product rule tells me I do the derivative of the first, which is just negative 1. That looks familiar. Times the second without doing anything. And then the product rule says add. So I'm going to add. And now I'm going to take the derivative of the second. Well, the second is this whole thing right here. So first I notice it's being raised to an exponent, so I bring that exponent right down here as a negative 1. Don't do anything to it yet. And then make it negative 2. Then differentiate inside. And the derivative of the inside is just 2x. All of that is the derivative of the second. Well, you're starting to notice some of the parts. I'll show you some of the parts in a second, but that is the derivative of the second. It is right here. Now I have to multiply it by the first. So I'm just going to squeeze in a 1 minus x at the end. So this is how they're expecting us to use the product rule to answer the same question. It does get a little bit more complicated, but let's just break it down if we try and simplify. So first I'm noticing that this is being raised to a negative exponent. So since it's being raised to a negative exponent, it can go on the bottom to the power of 1. So already you're starting to see characteristics of this part. Secondly, because all of these bottoms will turn into a negative 1, when you differentiate it, that negative 1 becomes here, and this plus can become a minus. So it's minus right there. So again, now you're starting to see the minus part of the quotient rule. Next, I see this part is going to go on the bottom, because it's being raised to a negative 2. So I'm going to put that part on the bottom. And I'm left with that minus, well that's up here, the 2x and the 1 minus x. So I'm just going to write it as 2x and the 1 minus x. So again, you're starting to see characteristics. The bottom is starting to look like the bottom of our quotient rule. In fact, in order to subtract these two fractions, I need to find a common denominator, and the most logical one is already there. 1 plus x squared all squared. I asked myself, what do I multiply by this to get this? Well, I multiplied it by 1 plus x squared. I had one of them here, and then I ended up with two of them, so I must have squared it. So the top has to get multiplied by that. The top is a negative 1, and it gets multiplied by one of these. Next, on the other side, the denominator hasn't changed, so I don't need to multiply anything on the top. It's just going to be as is. Normally I would rainbow this, but I'm going to show you how this actually ends up being the quotient rule. So I'm going to keep the denominator since they're the same. And I'm going to subtract the numerators without actually multiplying. And if you look closely, you'll actually see that that line right there is the same as the first line of the quotient rule. You see this and this are exactly the same. This -1 came from the derivative of the top. The next is times the bottom, minus the derivative of the bottom. So there's the derivative of the top times the bottom, minus the derivative of the bottom, which is just 2x, times the top, all over the bottom squared. So my argument is, why would we switch all of these quotients into products if they end up looking just like the quotient rule anyways? So we might as well learn the quotient rule, because we'll be able to get to this line right away instead of having to do all of this to get to the same line. And that's why we're learning the quotient rule.